Hey, it's your tutor Courtney Waterman, lover of anime, manga, and math. And this is another session of Tutor Me Senpai. Welcome back, everyone. I'm Courtney, and this is another session of Tutor Me Senpai. Today we're going to be jumping into a 10th grade topic, completing the square. However, for today's example, we're not just completing the square for the sake of doing it. Today we're going to be using the technique of completing the square in order to find the value of our quadratic equation. If you've never heard of completing the square, don't worry, I'll walk you through the steps in a moment. If you have heard of completing the square, you'll see another way we can use completing the square besides finding the factors of our quadratic equation. Before we jump right into our example, I would like to once again give you one more reminder that if you have any questions about this or any topics that you might be going over at home, feel free to leave them in the comments or visit me on Facebook at Tutor Me Senpai. If you find this video helpful, make sure you leave a like and hit that subscribe and notification bell so you can see whenever I drop more videos. Without further ado, let's jump straight into our question for today. So today's question is going to ask us to complete the square in order to find the minimum or maximum value of our function. Now, I don't want you to get confused, so before we jump into doing all the steps for completing the square and walking through all of that, I want you to realize what this question is asking. Instead of the usual factoring in which we find the x values of our function, this question is asking for us to find the minimum or maximum value of our function. That is the overall value that our function equals. So you can kind of rewrite this in this fashion. Instead of finding the x's that we normally do, today we want to find the minimum or maximum y. To further understand this question, let us look at what a parabola looks like, a quadratic equation. Normally, for an x squared, you have something like this, in which you have both sides going off into infinity, growing with no limit, but the bottom has a very clear minimum. Likewise, if you had a negative x squared, both sides are growing to negative infinity with no limit, but you have a clear maximum. So when it's asking for us to find the minimum or maximum, it's because this is a quadratic and we're going to have a minimum or maximum. So we want to find if it's a positive, like in this example, the minimum, or if it's a negative, like in this example, the maximum value of y. Another thing to consider in both of these examples, including the one I just erased, this is at 0. So the minimum and the maximum are at 0. However, this can move up. If you have a x squared plus 10, for example, then our function moves up the y-axis to 10. So the new minimum, unlike here we're at 0, the new minimum is going to be at y equals 10. Likewise, for the negative x squared, if you add or subtract anything from that, it's going to shift you up or down and you will get a new maximum. So that is what the question is asking for. I just want to put some more clarification on what it's asking before we jump into the question for today. So now that we know it's asking for the minimum or maximum or the highest point, lowest point of our quadratic, let's look into completing the square and how we're going to go about doing that. So the first step I like to start with is understanding what completing the square means, or what it actually looks like. When we have a quadratic that's in square form, it has this pattern. X's in both set of parentheses, the same sign, and the same number. It has to have this pattern if it's going to be a true square. So using that knowledge, we can then go to our second step and then FOIL this out. So if we start here, knowing that our quadratic is a square, It has to have the same sign, and it has to have the same number, and when we FOIL it out, we're going to get a quadratic in this form. The next thing I want to do is rewrite this so we can manipulate it a little bit. So we want to inject a square, something like this, into here, but we don't want to change the value of this quadratic. Changing it into something else, as far as value goes, does not solve this question. So we want to preserve the value, but change its looks. So the first thing that comes to mind for me is, well, if I want to change something, but I don't want to change its value, let's add 0 to it. Now, you might not think that adding 0 is going to change anything, because adding 0 to anything doesn't change anything, right? That's the whole point. Adding 0 keeps the value the same, but I can change how 0 looks by simply adding some random number and subtracting some random number. By doing this, I'm effectively adding 0, except I'm adding a number here and subtracting the same number here. So this is how we're going to inject a square into this equation when it didn't have one originally. But you might be asking, what the heck are these numbers? I can't just add anything, right? Well, technically, you don't have to. We're going to figure out what those numbers are based on our second step. So if you look at this part of our function and compare it to our second step, you realize they have some of the same format here. We have an x squared and x squared. We have plus some coefficient times x, plus some coefficient times x, and then we have plus a constant, right? So if we pair these up, x squared to x squared, 4x to this plus 2ax, so 4x equals 2ax, and this number, whatever that random number is, equal to a squared, we get a little bit more insight as to what these numbers potentially are. So the first thing I want you to notice is this number is definitely just a squared, right? If we're comparing apples to apples here, this is in the same spot as a squared, so we can just automatically rewrite this as x squared plus 4x plus a squared minus, remember it's adding and subtracting the same number, we want to make sure we're adding 0, minus that same a squared minus 2. But now you're like, what the heck is a? I have this a squared, based on this stuff that you wrote up here, but I don't know what the heck this a is. Well, that's where this comes in. Because they both have x, you can kind of cross out the x. We don't really care about that. We just care about the 4 equals 2a. Because 4 equals 2a, we can solve for a and know that it is 2. A equals 2. So let's just plug our 2 into every place we have an a. And we rewrite this to look like, what's 2 squared? 4. And we're going to subtract the same 4. Remember, we want to always make sure we're preserving that 0. Okay? So you might be tempted to add all these numbers together, but don't do that. Do not do that. You're just ruining the work that you just did. Don't add all these numbers together. Instead, you see how we broke this off and compared it to our step 2? I want you to do the same thing. Break this off and compare it to step 2. Now you have x squared to x squared, 4x to plus 2ax, 4 to a squared. And we know that a is 2, so these match up exactly now, right? Well, what do we know about this? Well, this is a square. Because we got it directly from foiling a square, we know that we can go back to this. Therefore, we can rewrite this in the form of this square in our step 1. x in both have the same sign. This is a positive 2. And a in both means the same number in both, because our square that we forced into our equation looks like our step 2. We can then rewrite our square like we did in step 1. Hence why these 2 steps I feel are very important for the completing the square method. Now that we've taken care of this, we have this left over. We don't want to get rid of anything, thus changing the value of our function. So we combine these now. -4 minus 2 gives us a -6. So this is another way of writing this. These 2 are exactly the same function. We haven't changed anything. We just added 0. It looks different, but this is going to help us solve this question now. This is what we call completing the square. We have a square that we kind of forced it in by putting some numbers, separating some things, and we ultimately got a square. But we have this thing left over. Well, if you remember the example of our quadratic moving up and down the y-axis, it looked like x squared plus some constant. Well, plus or minus some constant. So if it's plus or minus c, that means c is going to be our minimum in this case, or our maximum in this case. Well, this can be rewritten in this form because they're both the same and they're both being multiplied to each other. X plus 2 squared minus 6. Well, x plus 2 squared, that's just shifting things to the left and the right, right? So that means this is essentially the same or similar, not the same, similar to an x squared minus 6, just shifted over. So if we know by adding and subtracting a coefficient from x squared gives us a minimum or maximum value, then we know that adding or subtracting a coefficient to x plus 2 squared will do the same thing, which ties back to our question. Our question asked us to complete the square to find the minimum or maximum value. That is, what is the minimum or maximum value of y? Because this is a positive quadratic, because there's no negative right here, we know that we're going to have something that looks like this. Therefore, we're going to have a minimum but no maximum. And our minimum is going to be shifted from our y-axis of 0 down by 6. So our new minimum for our whole function is going to be -6. So that concludes another session of Tutor Me Senpai. Today we dove into a 10th grade topic, completing the square. However, we didn't stop there because we used completing the square in order to find the minimum and maximum value of our function. Now today had a lot of steps. Completing the square is not super intuitive at first, but as you practice, it becomes a lot easier. If you have any questions about what we went over here, please leave a comment because I would love to try to address whatever I can. If you have questions on this or any other homework that you may have, and the comment box is not big enough, why don't you visit me on Facebook at Tutor Me Senpai. If you like how I break things down and you would like to see more videos like this, why don't you leave me a like? It really helps the channel. Why don't you also hit that subscribe button and that notification bell so you know exactly when I drop my next videos. If this was difficult, please don't be discouraged. Sometimes math can get difficult, but I know that you will get it. That's all the time I have for today. I'm Courtney, and this is another session of Tutor Me Senpai.